In the early 1960s, the United States was facing a systemic blind spot. The U-2 spy plane, once thought to be untouchable because of its extreme altitude, had been patched by Soviet surface-to-air missiles. The game had changed. To survive, the CIA didn't just need to fly high, they needed to fly so fast that the very air around them turned into a weapon. This was the birth of Project Archangel and the SR-71 Blackbird, a machine designed to operate in a physics dead zone where conventional aviation logic simply ceased to function. The first hardware conflict engineers faced was the heat barrier. At Mach 3.2, over 2,000 miles per hour, the friction of air molecules hitting the nose and leading edges of the wings generates temperatures exceeding 600 degrees Fahrenheit. Aluminum, the standard material for every plane at the time, would lose its structural integrity and melt like lead at those speeds. To fix this thermal glitch, Lockheed's Skunk Works had to source a material that was notoriously difficult to work with: titanium. In a strange irony of history, the U.S. had to set up shell companies to buy the high-grade titanium from the Soviet Union, the very country they intended to spy on. The Soviets literally provided the source code for the plane that would haunt their radar screens for decades. But titanium created its own manufacturing error. The metal was so hard that it destroyed standard drill bits in seconds, and if it touched the chlorine in city tap water, it would become brittle and shatter. The entire factory had to be hacked with specialized tools and purified water systems just to handle the plane's skin. Perhaps the most famous design exploit of the Blackbird was the leaking tank anomaly. Because the plane would heat up so intensely in flight, the metal skin would expand by nearly a foot in length. If the engineers built a tight sealed fuel tank on the ground, the expansion at Mach 3 would cause the aircraft to literally rip itself apart from the inside out. Their solution was a counterintuitive patch. They built the plane with loose-fitting joints and no internal fuel bladders. On the runway, the SR-71 would bleed its specialized JP7 fuel through the gaps in its skin, creating puddles of fuel under the jet. It was only after takeoff, when the heat of friction caused the titanium to overclock and expand, that the gaps sealed shut, making the aircraft fuel-tight. This was a machine that was broken on the ground so it could be perfect in the stratosphere. To get it into the air, the crew had to use two massive Buick V8s just to jumpstart the jet turbines, a legacy boot-up for a machine that looked like a spaceship. Once in the air, the Blackbird wasn't just flying, it was glitched into a state of permanent acceleration, preparing to enter the airspace where it would become the Mach 3 ghost that no missile in the world could catch.
The heart of the Blackbird's speed glitch wasn't just the airframe, it was the most complex hardware hack in aviation history, the Pratt & Whitney J58 engine. To fly at Mach 3.2, a standard jet engine becomes a liability. At those speeds, the air entering the intake is moving so fast that it creates a system overload, generating temperatures and pressures that would normally cause a jet engine to flame out or explode. To bypass this, the J58 was designed as a hybrid exploit, part turbojet, part ramjet. The mechanical code behind this was a series of 6 massive bypass tubes. At lower speeds, the engine acted like a normal turbojet, providing the thrust needed to get off the ground. But as the Blackbird accelerated past Mach 2, the system logic shifted. The engine used a set of movable spikes or cones at the front of the intake. These spikes would move back and forth based on the airspeed, hacking the physics of the incoming air by creating a series of shock waves. These shock waves slowed the air down just enough for the engine to swallow it without crashing the system. Once the plane hit the Mach 3 sweet spot, the engine underwent a data reroute. Most of the air was diverted around the core of the engine through those 6 bypass tubes and sent directly into the afterburner. At this point, the J58 effectively became a ramjet, a high-speed engine with no moving parts. The faster the Blackbird flew, the more efficient the engines became. While every other plane on Earth burned more fuel to go faster, the SR-71's efficiency glitch meant it actually gained performance the harder it was pushed. It was overclocking the very atmosphere to stay in the sky. However, this power came with a terrifying stability error known as an unstart. If the intake spikes moved even a fraction of an inch out of sync, or if the airflow was slightly interrupted, the shock wave would be ejected from the engine intake. This caused an instantaneous loss of thrust on one side of the plane, a system crash that would slam the pilot's head against the cockpit canopy and pull the aircraft violently to the side. At 3 times the speed of sound, an unstart was like hitting a brick wall in midair. The only way to reboot was for the pilot to manually cycle the engine controls while hurtling through the stratosphere, a high-stakes troubleshooting mission performed at 80,000 feet. This engine exploit turned the SR-71 into a kinetic god. It wasn't just a plane, it was a continuous explosion contained within a titanium tube. By the time the Blackbird reached its cruising altitude, the engines were gulping down enough air to vacuum out a suburban house in less than a second. This wasn't just flight, it was a reality hack that allowed the U.S. to turn the sky into a high-speed highway where the speed of sound was just the starting line.
The final layer of the SR-71's speed glitch was its ability to perform a system deletion whenever the enemy tried to intervene. For 3 decades, Soviet and North Korean air defense networks viewed the Blackbird as a bug in their radar code, a target that appeared, moved too fast to be tracked, and vanished before a solution could be calculated. The SR-71's defense was built on a singular, arrogant philosophy. The interceptor is irrelevant. When a Soviet SA-2 or SA-5 missile locked onto a Blackbird, the engagement logic of the time dictated that the pilot should perform evasive maneuvers, diving, turning, or deploying chaff. But in the SR-71, the tactical hack was much simpler. The standard pilot manual for a missile launch was to simply push the throttles forward and climb. This created a lead time error for the missile's computer. Most surface-to-air missiles were designed to intercept a target by predicting where it would be in 10 seconds. But because the Blackbird could accelerate to Mach 3.2 and climb to 85,000 feet simultaneously, it outran the missile's ability to math. By the time the missile reached the intercept point, the Blackbird had already glitched out of the kill envelope, leaving the missile to explode in empty air miles behind it. The Blackbird also utilized an early form of stealth exploitation. Its surface was coated in a specialized iron ball paint that contained microscopic ferrites. These particles absorbed radar energy and converted it into heat, effectively downloading the radar waves instead of reflecting them back to the sender. Furthermore, the massive heat plume from the J58 engines was mixed with a cesium-based chemical additive. This created a plasma shield in the exhaust trail that absorbed radar pulses, making the plane look like a distorted ghost on enemy screens rather than a solid object. It was a cloaking glitch that turned the jet's most obvious signature, its heat, into its most effective shield. The most famous execution of this speed was the 1986 mission over Libya. After U.S. bombers struck targets in the country, the SR-71 was sent in to perform a post-strike audit. Libyan missile crews fired everything they had at the lone jet.
The pilot, Brian Schul, famously pushed the aircraft to a forbidden clock speed, exceeding the official Mach 3.2 limit. The aircraft was moving so fast that it crossed the entire country in minutes, leaving the Libyan missiles to harmlessly detonate in the Mediterranean Sea. It was a live server test that proved no weapon on Earth could catch a ghost moving at 35 miles per minute. By the time the SR-71 was retired, it had successfully evaded over 4,000 missile launches without a single scratch. It remains the only unpatched aircraft in history, a machine that won every engagement simply by refusing to play by the enemy's rules of physics. The Blackbird wasn't just a plane, it was the final boss of the Cold War skies, proving that if you move fast enough, you don't just win the war, you delete the enemy's ability to even fight it.